Alright, so this is our lesson on solubility curves. If you missed it in class, or if you were confused when we were going through it in class, you can watch this video and hopefully it will kind of clear some things up for you. Okay, so first of all, let's look and see what a solubility graph looks like. Basically what the solubility graph shows you, and the notes on the front kind of explain this. By the way, these notes will also be on Edmodo, so you can print them for yourself if you were not in class. But if you look at the x-axis, you see temperature in degrees Celsius, and temperature increases from left to right. And then you see solubility on the y-axis. Remember, solubility is the number of grams of solute that will dissolve in 100 cubic centimeters of water. And it's not just any number of grams, it's the maximum amount. If you remember what solubility means the maximum amount of a substance that can dissolve into 100 cubic centimeters of solution or solvent. In this case, this graph is referring to the solubility in 100 cubic centimeters of water. So solubility also, as a graph normally does, it increases from bottom to top. So what you can notice here is that most of these lines, each line is for a different substance. Most of the lines start off in the lower left and then move to the upper right. So what that says is, in general, most substances become more soluble as you heat them. Even sodium chloride, that looks pretty flat, does show a very slight increase as you increase temperature. So it starts off maybe around, I don't know, 36 or something like that, 34, 36, and it very slightly increases as you heat it. So that's what a solubility curve or a solubility graph looks like. Most of the time, one of these graphs is going to have multiple substances plotted all at the same time. You usually don't see a graph with just one line on it. Usually it's a bunch of substances on the same graph. Okay, so the notes pretty much go through what each axis is referring to, the general trend, which we just talked about, and then here's an example from lab 4.4. In lab 4.4, substance B was potassium nitrate, and basically what we observed in the lab is that as we heated it, it became a lot more soluble. So now we can compare it to what we know of potassium nitrate. Room temperature is right around here. So at the very beginning of the lab, the solubility was probably around 38, maybe 38 grams per 100 cubic centimeters. But as we heated it, more and more and more of the substance dissolved. And that's what the line shows us. So we do have something that we did on our own to kind of go along with the graph, and so that we can see the trend and we have in mind what that actually looks like in practice. So here are some examples. So we can use the solubility graph to figure out the amount of solute that can dissolve in 100 cubic centimeters of water at different temperatures. For example, and let's see if I can find a graph to just put side by side so we don't have to keep flipping. This one says at 20 degrees, 10 grams of potassium chlorate can dissolve in 100 cubic centimeters of water. So here's where that is on the graph. It says at 20 degrees, so here's 20 degrees down here, and we're looking at potassium chlorate, which is this line right here. So at 20 degrees, what we're going to do is we're going to follow that up, and the point at which it intersects with the line tells you its solubility. So at 20 degrees, 10 grams of potassium chlorate can dissolve in 100 cubic centimeters of water. Now, if we look at 50 degrees for the same substance, at 50 degrees, we follow that up and see where it intersects with the line. At 50 degrees, we see that 20 grams of potassium chlorate can dissolve. So potassium chlorate, like most other substances, becomes more soluble as you heat it. Another example would be with potassium iodide. That's the second example on the front right here at 30 degrees, potassium iodide. So let's look at that one. So potassium iodide is this line up here. Let's see if we can back that up a little so you can see it. Okay. So potassium iodide is up here, and it says at 30 degrees. So here's 30. So I'm going to go all the way up here to where that intersects with potassium iodide, right here, and then I'll trace that over. So at 30 degrees, 180 grams of potassium iodide is the solubility. So this is the maximum amount of potassium iodide that can dissolve in 100 cubic centimeters of water at this particular temperature, which is 30 degrees. If we then heat that up and go up here to 65 degrees, we go 65 all the way up here to see where it intersects with potassium iodide all the way at the top, close to the top, we can see that 240 grams of potassium iodide is the solubility. So potassium iodide, the maximum amount of potassium iodide that can dissolve in 100 cubic centimeters of water at 65 degrees is 240 grams. Another way of saying that is 240 grams of potassium iodide is the maximum amount that can dissolve in 100 cubic centimeters of water at this temperature, which is 65 degrees. So those are some things that we can do, that we can, excuse me, that we can use this graph for in terms of being able to analyze it and look at it. Okay, so now what we want to do is let's take a look at the questions and go through those together. So you can kind of see some examples of questions you might see regarding a solubility graph. The first one says, how much potassium nitrate dissolves in 100 cubic centimeters of water at 80 degrees? The first thing I want to point out is when it says in 100 cubic centimeters of water. If you look at our graph, that's the standard, 100 cubic centimeters of water. So when you see this on here, you don't have to do anything with this number other than recognize that that's our standard. So now the question becomes, if you kind of take that out, how much potassium nitrate dissolves at 80 degrees? So what we want to do is find 80 degrees on the graph and find where that intersects with potassium nitrate, which is this line here. So 80 degrees, we're going to follow that all the way up here to potassium nitrate, and it intersects right here, so we'll go over and figure out what that amount is, and that amount is 170 grams. So 170 grams of potassium nitrate dissolves in 100 cubic centimeters of water at 80 degrees. That's the solubility. Now, I want to point out one other way that question sometimes might be worded. Sometimes you might see this exact same question, but instead of saying 100 cubic centimeters of water, it might say 25 cubic centimeters of water. Now that definitely tends to throw people off because the graph doesn't show us how much dissolves at 25, it shows us how much dissolves in 100. So what you would do if you see the same kind of question, but you see a different volume of water, go ahead and approach it the same way you normally would. So you would still want to look at 80 degrees and find where it intersects with potassium nitrate. And that tells you 170 grams will dissolve in 100 cubic centimeters of water. Okay? So once you get that part figured out, because this is what the graph tells us, now what you're going to do is just set up a proportion to figure out how much would dissolve in 25 cubic centimeters of water. So if I know 170 grams dissolves in 100, how much dissolves in 25? So your proportion would look like this. 170 grams dissolves in 100 cubic centimeters. So how many grams dissolves in 25? Now in this case, these numbers are really easy. All you've really got to do is divide 170 by 4, because this divided by 4 is that, so this divided by 4. And I think if you do that, it's like 170 divided by 4. It's like 42 and a half, yeah. So then you would say 42.5 grams will dissolve in this much water at that temperature. So I just wanted to give you kind of an extension, another way this question might be worded. So again, if you see a volume of water other than 100, the first thing you have to do is still find that temperature and that substance and figure out its solubility in 100. Then you would convert it to 25 by doing a proportion. Okay, so the next question says, at 25 degrees Celsius, how much sodium nitrate can dissolve in 100 cubic centimeters of water? So this again is our standard 100 cubic centimeters of water. So now we're going to find 25 degrees on the graph and see where it intersects with sodium nitrate. So 25 degrees is right here, and then sodium nitrate is this line. So we're going to go up here to sodium nitrate, and that intersects right at about 90 grams. So the answer to this one is 90 grams of sodium nitrate can dissolve in 100 cubic centimeters of water at 25 degrees. Number 3, at what temperature will 50 grams of potassium chlorate dissolve in 100 cubic centimeters of water? So this just flips it up on you. Instead of asking how many grams, it's asking you at what temperature. So what we want to do is find 50 grams on the solubility side, on the y-axis, and see where it intersects with potassium chlorate. So it tells us 50 grams, so here's 50, and let's see, potassium chlorate, that's this line here. So we're going to find 50, and we're going to go all the way over here to where it intersects with potassium chlorate, right there, and then we're going to see what temperature is at, and that temperature is 90 degrees. So you can do the reverse as well. Sometimes it says if this is the temperature, what's the solubility? And sometimes it says if this is the solubility, what's the temperature? So you just, again, we're basically just looking for where those numbers intersect, or where they meet the line right there. So this would be 90 degrees Celsius. All right, the next one says, number 4, what is the solubility of potassium nitrate at 60 degrees? So what you need to recognize, again, solubility is what's plotted on the y-axis. So we're going to report this answer in grams per 100 cubic centimeters. So what we want to do is find 60 degrees and see where that intersects with potassium nitrate. So here we have 60 degrees, and let's see, potassium nitrate is this line here, so we follow that up here to where it intersects with potassium nitrate. And an important thing to note at this point is to just be really careful to make sure you're looking at the proper line, because sometimes they cross over each other like this and it can be confusing as to which is which. So that's an important point as well, just to pay attention to which line you're looking at. So let's see, that's 60 degrees and potassium nitrate, that's this line. So the solubility is 110 grams per 100 cubic centimeters. 110. Okay, so 110 grams per 100 cubic centimeters. Remember that when we're looking for solubility as our answer, you have to report the proper unit of measure. So you can't just say 110. You have to say 110 grams per 100 cubic centimeters. Question number 5 asks, which substance is more soluble at 50 degrees? And then it gives us 3 choices. So what we have to do is find 50 degrees on the graph, and then find each of those lines and see which one has the highest solubility. So let's see, we have sodium chloride, which is here, and then we have sodium nitrate, which is here. Okay, so sodium nitrate is definitely more soluble than sodium chloride. And then what's our third choice? Potassium nitrate. Potassium nitrate, actually, and this is again where you have to watch the lines, at 50 degrees, potassium nitrate is right around here, and sodium nitrate is up here. So sodium nitrate has the highest solubility at 50 degrees. So this one would be sodium nitrate. And then number 6 is kind of a tricky one, but you're going to see some questions like this that are a little bit less straightforward than the other ones. So it says, at 55 degrees Celsius, 220 grams of potassium iodide is dissolved in 100 cubic centimeters of water. What do you think would happen if this solution cooled down to 30 degrees? So this solution that we're talking about is 220 grams of potassium iodide in 100 cubic centimeters of water. Okay. So there's a couple of ways that we can approach this. I'm going to give you the most direct way. Try to avoid confusion. What I would do with this, it says, what do you think would happen if this solution cooled down to 30 degrees? What I'm going to do is find 30 degrees and see where it intersects with potassium iodide. That's going to be my first step. So I'm going to look for 30 degrees and potassium iodide. So 30 degrees, here's 30 on the graph. And if I follow that all the way up here for potassium iodide, that is 180 grams. So I know that at 30 degrees, the maximum amount that can be dissolved is 180 grams, because that's what the graph tells me. The graph says if I find 30 degrees on the graph and see where it intersects with the potassium iodide, this is the solubility at this temperature. So the maximum amount of potassium iodide that can be dissolved at this temperature is 180 grams. Now it tells me that this solution is cooling down to this temperature. So this solution has 220 grams dissolved into the 100 cubic centimeters. If I cool this down to 30 degrees, at 30 degrees only 180 is the maximum amount that can be dissolved. So the difference between these two numbers, which is 40 grams, 40 grams is going to precipitate out of the solution. Because remember, the maximum amount that can be held at this temperature is 180. So whatever the amount is above 180, that's how much is going to precipitate out of the solution. So the answer in this case, well, you could answer this a few ways, because it just says, what do you think would happen? You could say a precipitate will form, but to be more precise and accurate, I want you to say 40 grams of a precipitate will form. So that's how you would answer that question. All right, there's a few other practice problems that I want to look at, just to give you guys some more exposure to these types of questions. This is a second worksheet that I gave out in class, so let's go through and work some of these problems out as well. All right, so it gives you a solubility curve. The first one says, express the following concentrations in grams per 100. So this is just giving you guys some practice in proportions. So if I have 40 grams dissolved into 50 cubic centimeters, they want to know how many grams would dissolve in 100 cubic centimeters. Okay, this one's easy because you know that to get from 50 to 100, you just double that number. So you can set up a proportion, you can cross multiply. In this case, the number kind of presents itself pretty easily. So 80 grams per 100 cubic centimeters would be the concentration in grams per 100. B is a little bit more difficult because it's not as easy to get from 3 to 100. So if we have 0.55 grams dissolved in 3 cubic centimeters, how many grams can dissolve into 100 cubic centimeters? So you can just cross multiply. Sometimes what I like to do is just divide this all the way out to get grams per cubic centimeter, and then multiply the whole thing times 100 instead of doing the proportion, which actually, if you look at it, the math is exactly, well, it's not exactly the same, but it's very similar. So what I'm going to do is do 0.55 divided by 3, and that gives me 0.18 grams per cubic centimeter, and then I'm going to take that and multiply the whole thing times 100, and I get 18.3. So this one turns out to be, well, I'm just going to say 18 since we're going to try to use significant digits here. 18 grams per 100 cubic centimeters. So that's the answer to part B. This is the answer to part A. And then C says we have 80 grams per 185 cubic centimeters. Again, you can just set up a proportion and say if 80 dissolves in 185, then how much dissolves in 100? I, again, really prefer to divide the whole thing all the way out and then multiply times 100. So I'm going to do 80 divided by 185. Is that right? Let me try that again. 80 grams divided by 185. Yeah, that's right. So that gives me 0.43 grams per cubic centimeter. And then I'm just going to multiply that times 100. Times 100 equals 43. 43 grams per 100 cubic centimeters. So that's just some practice, making sure you know how to convert back and forth from some other volume of solvent to 100 cubic centimeters, because that's going to be our standard unit of measure. Okay, so now we're going to use the graph again. This first question says, how many grams of Caviar are needed to create 100 cubic centimeters of saturated solution at 60 degrees? So again, this 100 cubic centimeters is our standard number, right? 100, that actually is a misprint, that should say cubic centimeters. So 100 cubic centimeters is our standard. So we don't have to really worry too much about that number right now. So now we're going to look for 60 degrees and where it intersects with Caviar. So here's 60, and then here's Caviar. This graph's a little bit more tricky because it's teeny tiny. It intersects right below that line, so let's trace that back. So it's kind of like right below here. So that's probably 90. So I'm going to say that that might be 88. So I'm going to say 88. 88 grams of KBr is needed to create 100 cubic centimeters of a saturated solution at 60 degrees. Question 3 says, how many grams of NaClO3 are needed to create 25 cubic centimeters of a saturated solution at 20 degrees? So here's where it gets tricky, and I told you guys about this a minute ago. This one is saying a 25 cubic centimeter solution. This one is saying 100 cubic centimeter solution. So the first step, forget this for now. The first step is to say, okay, well, how many grams of this dissolve at 20? So we're going to do that part first. That's always the first step. Use what you already have. So 20 degrees, and then here's the line for NaClO3. So we're going to go all the way up here. It intersects right here at 100. So 100 grams will dissolve in 100 cubic centimeters at 20 degrees Celsius. Okay. So now we're not done yet, though. We found where it intersected, but now it says if 100 grams dissolves in 100 cubic centimeters, how many grams will dissolve in 25? So we can set up a proportion. These numbers happen to be really nice and neat, which is easy because you know to get from 100 to 25, you divide by 4. And this number is also 100, so you divide by 4, it's 25. But from a mathematical perspective, if the numbers aren't so simple, you can cross multiply, where you would multiply these two numbers and then divide by this number to get x. Okay. The other thing you could do is divide this all the way out, 100 divided by 100, and then multiply the whole thing times 25. And that would give you the same answer. In this case, we need 25 grams. That would be our final answer for this one. All right, I told the students in class to disregard this one. We're not going to worry about that one right now. So let's flip this over on the back and look at a couple more. Question number 5. A student dissolved 70 grams of KNO3 into 100 cubic centimeters of water at 50 degrees. Okay. The next day she returns to her solution and half of the solvent has evaporated. Temperature remains at 50. Is this new solution saturated, unsaturated, or supersaturated? We're not going to do that one either. I'll have to tell everybody. I'm not worried about that type of question. Let's look at number 6. A student creates a solution at 110 degrees that has 80 grams of KBr dissolved in 100 cubic centimeters of water. At what temperature will a precipitate start to form? Okay, this is a good question. The good news here is that, again, luckily, this is supposed to say of water. They're using the standard amount of water that the graph already shows us, so we don't have to worry about that number. So it says 110 degrees, 80 grams. So we have 80 grams per 100, and that's at 110. Okay, at what temperature will a precipitate start to form? So let's see. Let's look at our graph. We have 80 grams of KBr. Here's KBr. And it's heated up to 110 degrees. Let me just make sure I'm doing my numbers right. So we have 80 grams KBr at 110 degrees. That's all the way down here. Which, by the way, is impossible because water boils at 100, and so that's not really possible to have the temperature over 100, but for the sake of argument, we'll just go with it. So 110 is right around here. So 80 is totally dissolved. 80 at 110 is like right around here. Okay. It says, at what temperature will a precipitate start to form? So basically what we're looking for is if I cool this off, and I cool it off, and I cool it off, and I'm at 80 grams, and I cool it off, and I cool it off. Right here, the temperature at which 80 grams is totally dissolved, which is 50 degrees, when I get to this point here, and I keep cooling it down, this is the temperature where it intersects with a line where a precipitate will start to form. So the answer is 50. So when you're looking for at what temperature will a precipitate start to form, find the number of grams that you have and find where it intersects with the line at that temperature. That's where it's totally saturated, and as we're moving from a higher temperature to a lower temperature right past that point, right there where it intersects the line, that's where it's going to start to precipitate. So the answer to that one is 50 degrees. Let me turn that over. So 50 at 50 degrees Celsius. That's kind of a tricky one. This one's tricky too. A student creates a solution at 75 degrees that has 25 grams of NaClO3 dissolved in 15 cubic centimeters of water. At what temperature will a precipitate start to form? So it's the same process as this one, except this time it's 15 cubic centimeters of water, not 100. So what we need to do first is it says 25 grams of the substance is dissolved in 15 cubic centimeters of water. So what we want to do is convert that to grams per 100, because that's what our graph shows us. Our graph shows us grams per 100. So I need to convert that first before I can do anything else. So 25 divided by 15 times 100. Okay, so we're looking at 167, right around that much. 167 grams of NaClO3. Okay, and then it starts off at 75 degrees. So it wants to know at what temperature a precipitate will start to form. All I have to do is find at what temperature, or the temperature at which this is totally dissolved, and that's the temperature a precipitate starts to form. So let's find that. 167 and NaClO3. So let's see, here's NaClO3, this line up here. Let's see if we can get scoops in a little bit so you can see it. Okay, so 167, let's see, there's 160, there's 180, that's 170, 167 is kind of below this line a little bit. So maybe like right around here, I'm going to say. And of course that part's covered up with the name of the substance. But we're getting in the ballpark at this point is just fine. So we'll go right around here, and we'll say this temperature is, if that's 60, 65, 70, 75, 80, so that's 65 degrees. Okay, so if I start off, if the temperature starts off at 75, a little bit higher, and it starts to cool off, and I have 167 grams, I already figured that out. So it says at what temperature will a precipitate form? The precipitate will form at the point where 167 grams intersects with a line at that temperature, which is 65 degrees. So it's the same process, so the answer is 65 degrees Celsius. So we follow the same process that we did with this one, but first we had to convert it to grams per 100 before we could figure out the temperature. Okay, two more. You create 100 cubic centimeters of saturated solution of KNO3 at 20 degrees. If you raise the temperature to 60, how much more solute could you dissolve? Ooh, this is a great question. Okay, so the good news is 100 cubic centimeters, that's our standard, so we don't really have to do anything there. So if we create a saturated solution at 20 degrees of KNO3, so at 20 degrees, and then KNO3 is right here, follow that line down here. Okay, so at 20 degrees, if I created a saturated solution of KNO3 at 20 degrees, that means I used 30 grams. Okay, so I'm going to write that down just so I know it. So 30 grams per 100 is the solubility at 20 degrees. Okay, so 30 grams. So right now it says I created a saturated solution of KNO3 at 20, which means I used 30 grams. So this is the key number right here, 30 grams. If I increase the temperature to 60, how much more solute could I dissolve? Okay, so let's find 60. So here's 60 on the graph, and then here's KNO3. Let's find that all the way up. Make sure you look at the right line. That's tricky sometimes. So 60, and that's KNO3, and then we're going to follow it over here. That's 110. So 110 grams can dissolve in 100 cubic centimeters of water at 60 degrees. Okay, I started with 30 because I created this saturated solution at 20. So I started with 30 grams, I heated up to 60, which means I can dissolve 80 more grams. So if I have 30, but 110 is the solubility, so I can dissolve 110 grams at 60 degrees Celsius. I started with 30 grams, so the difference between those two is 80 grams. So I could dissolve 80 grams more of my solute at 60 degrees. So basically you find your starting temperature. The solubility at the starting temperature is 30. Then you find your ending temperature, 60. Its solubility is 110. And then you just find the difference between the two. Last one. You create you create 45 cubic centimeters of a saturated solution of KBr at 80 degrees. 45. Again, they're not using our standard, so let's do this first. KBr at 80 degrees, and it's saturated, so let's find that first. 80 degrees, okay, and then KBr is this one. Okay, of course it's a number that's right in the middle between the two. So we go over here, between 90 and 100, so we're going to say 95. 95 grams dissolves in 100 cubic centimeters at 80 degrees. Okay, but my saturated solution is 45 cubic centimeters, so now I have to take this and convert it to 45 cubic centimeters. So 95 over 100 is equal to x over 45. I like to do 95 divided by 100 times 45. Okay, so that means 42.75 grams. So that's how much KBr that I had to use to create a saturated solution of 45 cubic centimeters at this temperature. Okay, so if I drop the temperature to 10 degrees, how much precipitate will start to form? If I drop it to 10 degrees, how much precipitate will start to form? Okay, so let's look at this. At 10 degrees, KBr. I'm going to look at KBr at 10 degrees. So there's 5, 10, 15, 20. So it's here. KBr. Is that the line for KBr? Okay. At 10 degrees, of course the numbers can't be even. So if that's 60 and that's 70, that's probably 65. So 65 grams dissolves in 100 cubic centimeters at 10 degrees Celsius. Okay, so what I have to do then, if I drop the temperature, I want to know how much precipitate forms. But I've got to take this and convert that one also to grams per 45. So let's do that first. Wait a second. Oh, okay, I got you. So 65 divided by 100 times 45. Okay, is 29.25 grams. Okay, so if my solution is only 45 cubic centimeters, I started off with this much completely dissolved, and I lowered the temperature to where this is the maximum amount that can be dissolved. So the difference between these two is what's going to precipitate out. Because again, once I lower the temperature, I can't have any more than that dissolved in the solution. So anything above that is what's going to come out of solution. So I'm going to subtract those two. 42.75 minus 29.25 is 13.5 grams of precipitate. This is my answer right here. That is a tough question. There are a few of these test questions which we'll look at in class tomorrow, but if you made it through all of this with both practice worksheets, then you're going to be in really good shape for the test questions.